Lesson 10-0, square roots. Our essential question is, how do you approximate a square root without using a calculator? It's really important skill for you to have because when we take our MCAs this year, you are probably not going to be able to use a calculator when you're working with square roots and rational and irrational numbers. So we're going to teach you today how to do this, how to make approximations without a calculator. First, as a review, hopefully everyone can name the first 10 perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 9, and 10. Remember, you really need to have those memorized, at least the first 10 perfect square numbers. Okay, these numbers are not perfect squares. Find the integers that they lie between. This is also a review from when we worked with number lines a few days ago. So I am going to review with you that when we look at a number line with integers on it, you want to think about these as perfect squares. These are negative roots. And then on the other side, of course, are positive. And it could be that I kind of don't have enough room for some of my numbers. So we'll see if I can slide anything down. Okay. Okay, it's a little bit better. The first one, you can see though that I still kind of don't have enough space because after the square root of 64 over here, 9 would be the square root of 81, and then 10 is the square root of 100. So the square root of 70 would be between 64 and 81. So it's between the square root of 64 and the square root of 81, which means it's between 8 and 9. The next one, negative square root of 55. 55 is between 49 and 64. So it's going to be between negative 7 and negative 8. 41. 41 would be here between the square root of 36 and the square root of 49. So it's between 6 and 7. Negative square root of 23, that's going to be in here. So it's between the negative square root of 25 and the negative square root of 16. So negative 4 and negative 5. The square root of 38 is going to be over here again. So it's between the square root of 36 and square root of 49. So 6 and 7. And then the negative square root of 18, here again. So between negative square root of 16 and negative square root of 25, so negative 4 and negative 5. So knowing your perfect squares is really important to being able to estimate which two perfect squares a non-perfect square is between. Find a reasonable decimal approximation for each of these square roots. So our first square root that we're working with is the square root of 41. The square root of 41 is in between the square root of 36 and the square root of 49. Now, to estimate, so we know that it's going to be between 6 and 7 then, but to estimate it, you want to think about how far the number is, how far away the number is. So 41 is 5 away, it's 5 away from 36, and it's 8 away from 49. So that tells me that my number is going to be closer to the 6 than it is to the 7, because 36 to 41 was only 5, so it's a little bit closer. So I am going to say it's between 6 and 7, but it's closer to 6, so I'm going to go with maybe 6.3 for my estimate. The next one, the square root of 13, is in between the square root of 9 and the square root of 16. So it's between 3 and 4. And how far away is it? It's 3 away from 16, and it's 4 away from 9. So it's pretty close to being in the middle, but it's a little bit closer to the 4. So I'm going to approximate it as 3.6, because 3.5 would be right in the middle, and it's close to being in the middle. The last one, square root of 70. This one is in between 64, which is 8, and 81, which is 9. How close is it? From this one, it's 6 away. This one, it's 11 away. So I would say it's significantly closer to 8. So I'm going to say it's about 8.3. 8.3. When you are finding a reasonable approximation, that just means that you need to be in the ballpark. So you should be able to decide what it's in between and hopefully figure out which one it's a little closer to. Okay, which of the following is slightly greater than square root of 53? Square root of 53. Well, 7 1/5. 7 1/5 is the same as, if I change this to tenths, 7 and 2 tenths. So 7.2. 7 2/3. 7 2/3 is the same as 7.6 repeating. Because 2 divided by 3, 3 goes into 2 0 times, 3 goes into 26 times, 3 times 6 is 18, so there's 2 left over, so it's going to keep on repeating that same pattern. So it's 7.6 repeating. 1/5, if you're not good at knowing that 1/5 is the same as 2 tenths, which is 7.2, you could divide 5 into 1.0. 5 goes into 10 twice. So that's how you could determine that 1/5 is 2 tenths. And then the bottom one, 7 3/10 is 7.3, because the first decimal place is tenths, and 3/10 again, if you needed to divide 3 by 10, add your decimal point and your 0. 10 goes into 3 0 times, but into 33 times. No remainder. Okay, so now our question is, which of these decimals is slightly greater than the square root of 53? I'm going to start out with the smallest one, and I'm going to multiply it by itself to see if it's 53. 2 times 2 is 4. 7 times 2 is 14. Move over a decimal place. 7 times 2 is 14. Carry the 1. 7 times 7, 49, plus 1 is 50. So I add these, 4, 8, so 51.84. So is that slightly greater than 53? No. So it's not 7.2. So now I try a different one. So let's try 7.3. Because 7.6 is a lot bigger, And I wasn't that far away. I was almost at 52. 3 times 3 is 9. 3 times 7 is 21. Move over. 3 times 7 is 21. 49 plus 2 is 51. So 9, 2, 3, 5. We found our answer. 53.29 is a little bit bigger than 53. So my answer is 7.3, which is 7 and 3 tenths. So I converted them all to decimals, and then I multiplied them by themselves, multiplied by itself to see what it's closest to. Okay, find the approximate value. 8 plus the square root of 22. Without a calculator, the square root of 22 is in between two perfect squares, 16 and 25. So it's in between 4 and 5, and it is closer because it's 6 away here, and it's only 3 away here. It's closer to 5, so I am going to use, as my approximate value, 4.7. 4.7. Now if you use something like 4.6, 4.7, 4.8, those are all going to be reasonable. Now when I add these together, remember 8 plus 4, this is 8 is like 8.0. So 8.0 plus 4.7 is just 12.7. So approximately 12.7. That's my estimate. This next one says find the approximate value. 3 times the square root of 12 plus 5 times the square root of 12. Well, the square root of 12 is being multiplied by 3 and being multiplied by 5. So this is the same as 8 times the square root of 12. You can simply add together the 3 and 5. It's just like 3x plus 5x, how that equals 8x. They're like terms. These are called like radicals. So you can add the numbers in front of them or subtract them if it was a subtraction problem. Now, let's approximate that square root of 12. Square root of 12 is in between the perfect squares 9 and 16. 3 away from 9 and 4 away from 16. So the square root of 9 is 3. Square root of 16 is 4. That's kind of odd how that worked out. But it's a little bit closer here. So a little closer to 3. So I'm going to say it's about 3.4. 3.4. So my approximate answer, I've got 8 times 3.4. So 3.4 times 8, 32. 24 plus 3 is 27. So it's approximately 27.2. By changing my equal sign to an approximate sign, that's just showing you that I'm rounding it, that I'm estimating. Next one looks similar to the last one. So this one I'm going to subtract those numbers in front because, again, I've got like radicals. So 9 minus 2 is 7. So 7 times the square root of 23. The square root of 23 is in between the perfect squares, 16, which is 4, and 25, which is 5. It's much closer, though. It's only 2 away versus 7 away. So it's much closer to 5. So I'm going to go with 4.8 as my approximation. So 7 times 4.8, 56, and then 28 plus 5 is 33, so it's about 33.6. When you're working on Study Island, you should see that as long as you're in the ballpark, if you do your approximation, there's usually only one answer that's even close. Most of them are far away. Okay, dividing. These I actually think are easier. Dividing is usually harder, but not so with these square roots. If I divide 9 by 3, I get 3. And then if I divide the square roots, I get 5. So now I can approximate my answer. The square root of 5 is in between perfect squares 4 and 9, and it's really close to 4. So it's in between 2 and 3. This one's 2, this one's 3, and really close, only 1 away. So I'm going to say 2.2. So 3 times 2.2 is approximately 6.6. So divide the numbers in front of the roots and divide the numbers underneath them, and then simplify. This one, just like the last one, only with multiplying, we're going to multiply the numbers that are in front, and we're going to multiply the numbers that are under the roots. So 5 times 3 is 15, 2 times 10 is 20. Now approximate that square root of 20. So it's between 25 and 16, so between 4 and 5, a little closer to 4, so about 4.4. So 15 times 4.4 is approximately 5 times 4 is 20, carry the 2, 22, move over, 4 times 1 is 4, so 66, so approximately 66. So multiply the numbers in front of your roots to simplify, and multiply the ones underneath. That's just using the commutative property to change the order of what you're multiplying. Okay, solve for x. Square root of x plus 4 equals 13. Well, the inverse of the square root is to square both sides. So if I square it, the square root is gone. So x plus 4 equals 13 squared, and then I can just subtract 4, and x equals 165. Next equation. On this one, you need to do the division first. So you'll need to divide the 4 on both sides. So x squared equals 8. Then do your square root. So x equals the square root of 8. And what you'll see in Study Island is the plus or minus, because technically there are 2 solutions here, a positive square root of 8 and a negative square root of 8. Multiplied by themselves would give you the correct answer. Next up, on this one, you divide first because we want the variable by itself. And I am going to leave it in fraction form instead of decimal, because then when I square both sides to get rid of my square root, it will stay a nice fraction. 289 is 17 squared, and 2 squared is 4. Each of these equations is just a little bit different, This one might look really tricky, but if you treat pi kind of like you treat a variable, what happens is I want my variables all on one side, so subtract away the smaller one, and I've got 7x squared plus pi equals 5 pi. I can actually subtract that 1 pi on both sides. 5 pi minus 1 pi is 4 pi. I'm not even going to multiply that out. I divide by 7, and then x squared equals 4 pi divided by 7, and I can just take the square root on both sides. So that's what my answer would look like. The square root of 4 pi over 7. And it could have a plus or minus sign in front of it, just like on the last one. Okay, last example. On this one, we are going to eliminate that exponent right away, which means the square root. So take the square root to cancel out the exponent, and it will look like this with the plus or minus in front, and then subtract your 3. So x equals -3 plus or minus the square root of 20. I know these are tricky, but if you have these examples written down, I think you're going to be okay to look through them and find something similar when you're working on your homework. So you should be able to write a summary now. And your homework is to finish your worksheet packet.